we know, like for the nature actually has inspired us a lot, such as the work skipper. We know it can work like freely on the water surface. And also another one phenomena is the lotus. Actually, we know it is the lotus effect for the super hydrophobic. And of course, for the butterfly, we see how beautiful of these species. Actually, there is a lot of examples of species showing like very smart and very beautiful structures. Such kind of materials actually and surface, we can find it widely in the nature. So these driven us to understand the basic principles such as the smartness, micro-mutation, hierarchical assembly, and adaptabilities. For this type of the smart surface, actually, we have a lot of applications such as anti-icing, anti-fogging, anti-corrosion, and especially for the inspiration from the gecko, we have the climbing robot, and for other like lotus surface, we have the waterproofed applications. So if we look common about this surface and also this species, we will look in deeply about how such kind of functions is attributed to. If we look at the gecko's feet, we can find it has actually have a hierarchical structures from macro to micro, even to the nanostructures. Actually, this is quite not similar to our human body. Like from the alive orientation, we insisted by the moleculars, and then by different kind of hierarchy level, we can consist into from cells, tissue, organic, even to the organisms, even for our human bodies. So this means the surface structure and also the surface composition can maintain all types of the functions. So here is introduced to my work. As we know, the marine equipment is actually it's very huge and also very important equipment in marine applications. However, there's a very serious problem like the fouling. Each year, for the fouling causes on ship, actually it is reported like estimated the economic loss were as high as 300 to 500 billions of dollars each year. It's because for the fouling, like it will increase the weight of the marine equipment and also will also make the corrosion of the surface. So this is the fact that we are facing too for the marine equipment. So how to solve these problems? Again, we also see the species. Firstly, let's look at the whales. As we know, if we compare the whales to the sharks, actually the surface is smooth. However, if we look at the shark surface, actually the surface is quite rough. And also from another point, like if we look at the lotus structure, the surface, after like a rainy day, actually, if the surface like covered by the dust, then after rain, the surface will be clean. So if we looked deeply about the surface, what the surface looks like, both of the lotus and the sharks actually show like a periods of structure, like a lot of is localized on the surface. For the lotus, actually the surface is like covered by hundreds of nanometers structures. And also for the wheels, actually there's covered by a lot of dendritic structures on the surface. However, these two structures actually in a different dimensional level, like for the lotus is nanostructures, for the sharks is microstructures. So from this point of view, we think about it, can we combine these two effects that to fabricate the surface that can maintain these two functions both of the drug reduction and also the surface clean. Then, based on this, we derived our experiments. Like we want to combine the surface, both have the shark structures and also the lotus nanostructures. So for the shark's skins, like looks similar structures, we use the microcasting. So here we use the shark's sample. After treatment, we pour the negative template and then get the negative template, and then use the micro casting again. We can obtain the replicated shark skin on the surface. Before it's totally curved, we use the nanospring spraying treatment. So here we use muscle silicon oxide. By using these materials, actually have a lot of functions, because one is similar to the nanostructures of the lotus structure. Another, in the potential applications, like it can also carry a lot of materials, which can be in future applications. And then by combining these two techniques, actually we can get a surface that is covering the lotus structure, looks like a surface on the shark's dendritic structures. So from A to D, actually, we can see here, there is the surface is covered by different concentrations of the lotus structures on the shark's dendritic. And then we test the performance of this composite surface. So firstly, we use the rheometer to test the drug reduction properties. From this figure, we can also see that, like after different modifications, actually the surface shear stress was reduced. So we can also find the ratio of the drug reduction here. Like we can achieve a very similar drug reduction efficient as compared to the real shark skin surface. And if we combine the nanosparing techniques, actually, this can also indicate our main structure for drug reduction is replicated the dendritics, and also for the deposit lotus structure, which will significantly amplify this effect under like a certain coverage, like under a concentration of 0.67 micro per milliliter, we can achieve the very high drug reduction. And for the antifouling properties, we use two methods. One is the organic antifouling properties, and another one is the microspecies antifouling properties. First, let's look at the antifouling properties by inorganic contaminants. So we use a method like we simulate the dust and then put certain amount of the dust on the surface, use a water flow, and then after that we dry and weight the surface and compare the weight before and after the experiment. As shown in this table, actually, our surface actually is show very high efficient in the antifouling properties. And for all the treatments, actually, we can see the antifouling properties actually was increased. And for this, and if we look at the efficiency of this composite surface, actually is tripled as compared to the surface with only with the shark's microstructure. And here we also observed the surface after we clean the surface. If we look at the XEM images, actually we can also see that like for the surface with both treatment actually show a very clean surface. And also we test the surface with adhesion test. We're using sloped stage. We can see here using the black ink and also the white milk. Actually, we can see here for this surface actually show very good performance. Like for all the liquids, actually there is no adhesion on the surface. All the droplets was moved very fast on the surface. So this decrease of the adhesion actually was the main reason for improving these self-cleaning properties. And then we use two experiments to check the properties by using the protozoom. And also we divided it in two conditions, a static condition and also the dynamic condition. The red X actually shows the location of the protozome's position. And also if we compare the surface actually under the static condition, the anti-adhesion performance was not improved significantly. So this, if we just see the nano modified surface, actually we see here it indicates the nano lotus structures has a good physical bacteria for decreasing the adhesion. And then we use the dynamic condition, like we use the water flow, so the water is dynamic, and then compare this result to the static one. Actually, we can find it. The numbers was decreased for all the samples. And here, if we just see this surface, actually the surface is very only a very few protozoa was on the surface. So this means if we can combine these techniques, actually the anti-adhesion performance will be significantly improved. So another important factor is to check out how was the lifespan of this such kind of surface. So we use a stability test. One is using the water jetting impacting experiment. First we check the surface weathability after the 10 hours water impacting. Actually, the surface conduct angle was kept quite stable. And if we check the microstructure of the surface, again we can see the surface also kept quite stable. And another test is using this abrasive wear test. Here we use sandpaper to abrasive to make the tribological test. And here we can also see if the surface without any treatment, actually there's a lot of grooves on the surface. And if we using different treatments, actually the wear resistance was improved. And this one, this surface was using both treatments has shown the best anti-wear resistance. Okay, for the mechanism, very interesting. When we observe the surface by using the optical microscope, actually we find there is a lot of not focus area. And if we analyze this area, actually we find it is very interesting. Actually, it's consisted by different types of the bubbles. So for surface with only modified it by the shark skin, actually the structures, because it is micro scale. So we also see here there's a lot of big bubbles. And if we see the surface with only modified by the lotus structure, actually the bubbles is distributed a lot, but the bubble size is very small, as shown in these optical images. If we combine these two, actually there's big and smaller bubbles, and also amount is a lot. So if we use this for the dynamic model, we can see that this can significantly improve the sleep distance. So this is the reason that why the surface is have an anti-drug reduction, especially for this type of the surface. And also we also test the surface wettability, because we check it. We can know that how was the surface adhesion by this way. If we check the surface wettability, we can find out by different treatment, actually, the wettability was improved. And if we combine these two techniques together, actually, this surface is the surface wettability was significantly improved. And also for the rolling conducting angle, we also call it conductor hysteresis. We can also see that this one actually shows the best anti-drag reduction performance. It also has a very high conduct angle and also low conductor angle hysteresis. So this means that if we using different techniques, we can make the surface change from the windsor model to the castle model. So if the surface is covered by different fouling materials, by this way, the droplets on the surface can rotary and also can bring these pollutants away, then make the surface in a cleaning state. So this is the reason and also the mechanism. Inspired by this, we invent no damage like a needle for transferring the droplets as shown in these pictures. So as we know that actually for the previous casting replication process, actually we can get a very complicated like a bio-inspired surface. But if we want to widely use such kind of materials, or these types of the structures is very difficult. So can we use the simple structures to simulate this effect by such kind of surface? And also from this simulation result, we can also get a very interesting results. Actually, such kind of surface can also maintain such kind of effect. And also, we can find the amount of the energy voltage was decreased if we improved the water flow velocity. So, inspired by this, we using another technique, like the laser texturing technique. So here, this is a laser. We put the designed pattern in the equipment, and then we fabricated such kind of the surface. And also we control the parameter, like for here, we can obtain the surface like with the simplify, but here you can see here is also very smaller and fine structures on the top. So by such kind of method, we can get a very simplified but also hierarchical structures on the surface. And by such kind of surface, we also check the drag reduction performance. As shown in these four figures, we also get a very good anti-drag performance. Actually, for our work, it's not suitable at the current moment. As we mentioned in the beginning, why we use the muscle silicon oxide nanoparticles, because it have a very huge volume capacity, and so it has a potential in loading some antifouling reagents. Such kind of structures, we also moving the work forward, like we fabricated the porous membranes, and then we will later test the anti-drag and also the anti-fouling properties. And also we know that for the shark dendritics, normally it is very flexible. So for the real shark, because the skin can be flexible and also can have a movement. So here we also want to adjust the mechanical properties of the dendritics on the surface by different modifications. So here we also have some like a simulation. We can see here this process. If we can adjust our surface like we can control the movement of the dendritics on the surface, then we maybe can control the surface by control the dendritic movement in changing the surface drug efficiency. Okay, so this is some recent publications